Hi, this is Zhenhua, and my responsibilities for this project is to build the backend servers based on Django and connect it with the MySQL to realize the file system control. Here, I want to introduce the overall architecture of our application. And there are two databases we used for this application. The first is the MySQL, and the second is the Firebase. My responsibility is to establish a Django to connect with the MySQL and establish some module and do some migrations to control the CRUD of MySQL. And I provided some REST frameworks and I designed some URLs, RESTful URLs, so that later the front end could fetch the data from the backend using the Axios HTTP request. Here I will introduce the diagrams of the file system and data size in MySQL. And this is the diagrams of the file system. There are three entities: path, relations, and the part. The path stores the path type, which is file or directory. And inode is the ID of this path. And the relations will store the inode of different paths, the parent and the child. It will donate the parent and child's relative relations between the different paths. If the path is the file type, it will also have the part. Part is the short of the partitions. And in the partitions, it will store the inode of this path, also with the locations of the other partitions. For example, the restaurants.csv will be partitions with the 2, and the locations of the partitions of restaurant will be stored at this part. And this is the architectures of the real data. And we provide for data site, city, restaurant, rate, users. City has these three attributes, also the restaurants. And the restaurant is in one city, and the user could rate restaurants, and it will have a score. All of the CSV file of the dataset will be converted into this overall architecture. And we will build these architectures during the partition part and using the post API. And I will introduce it later. So then I will introduce the module design. Since the Django is a little different from the SQL grammar, and it's just to use a thing called module and do the model migrations to revise the table. So I build the models for dataset in this for module, and file system is to these three models. And the partitions will become the child of this 4 module. For example, we could have the city 1 to city 0 to city 3, and the parents of the city partitions will be the city. You can think the inheritance relationship between the real data and the parent data and child data. This is parent and this is child. In fact, the data will be stored in the child. So the data will be stored in the 0, 1, 2, and the city won't contain any data. Now here I want to introduce the RESTful API for the overall file system. All the system URL endpoint will become the API commands. Get will support LS functions that you could you can list the contents of the subfolders. It just need to pass into the absolute path, also with the command check all path or check specific path, check one path. I thought there is a typo. Okay, this is check all path. Check all path is the admin used only, and all of the paths will be appears on the page using check all path. Client won't use this endpoint. Go back functions will help us to go back to the upper folders. And it is very important to use in our file system. CAT will show the CSV file stored in the file system. The put is admin use only. It will initialize the root folder. And delete, we could delete a specific path we could only provide up to path of this specific path. If it's a folder, and it will delete the folder also with the contents in the folders. This is admin use only. It could help us to delete all the paths. It won't be provided to the client side. It's really dangerous. Also, we will provide the post. The post will realize the maker and put function. And using these functions, we could partition to K part of the file. You could make the will use the type directory, and put will use the type path. And if it's a file that is put, and we could provide the K. The dataset API will do CRUD to connect the real dataset. And if we want to get the partitions informations, we could specify the restaurant in this URL, and the table number will show the partitions. If we participate into 3 parts, the table could be 0, 1, 2, also with other dataset. This is duplicated with the CAT previously before. And we could delete the restaurant. If we use delete, it will delete the partitions of the restaurant from 0 to K-1, also with the other dataset. The post data is important. It will help us to post the real data set into the database, also finish the partitions. For instance, we want to post the restaurant, we need to provide the path of this CSV file, also with the K. The K could be any numbers, and it will send from the front end. The front end will provide this K. Also, the partitions is based on the characteristics of this dataset. For example, the restaurant will be sharding based on the business ID. The first character of business ID and converted it to ASCII number and mode by K. The city is the ranking of the city mode by K. And REST user will be the REST user's ID, first character ASCII number mode by 3, and rate will be the rate number mode by 3. 3 is an example. It could be any number. It is K actually. And this is the relationship about the view. View is also a part of Django to write the API. And I established all view to put some general functions. If this character has specific functions, I'll put in the specific class of it. All of the endpoint could be tested into the Postman. This is the real data. You could get some real data in all of these endpoints. And the file system endpoint is like this. Okay, thank you for watching.
Hi, so my name is Izu, and I'll be talking about Firebase part of our project. So for our Firebase part, when we doing partitions, we just this is our logic. So we get all the data sets, and we will we set our K to be 3. And for the user and restaurant, we choose the first letter of one attributes and translate to ASCII letter and get its modulus of 3. Then we could get 3 partitions of these 2 data sets. And for ratings, we're just doing rating and uses modulus of 3 and also get 3 partitions. For city, we use ranking to get the 3 partition. That's how we doing partition in Firebase. Next, I'll be talking about how we're doing map reduce. So for our map reduce in Firebase, for example, if we want to query data about restaurants, we we take the user input and incorporate it into the Firebase API link, we just query through this link. For each partition, we do it 3 times. And after that, we could get 3 responses with the desired output. And we just combine these 3 output together into 1 query result. And then we can do some filter. If the user only want top 10 restaurant, then we can choose the top 10 and doing some order by things later. That's how we doing MapReduce. So for MapReduce in SQL, this is our MapReduce for SQL, especially for restaurant. So for restaurants, we first sort each restaurant. After we sort each restaurant, we put a pointer on the largest number in each sort. And we just begin to merge each partition by choosing the largest of the 4 pointers. And we merge them together to get K review count restaurant. That's how we doing restaurant partition, MapReduce in SQL. And for the city, we just get the top K population ranking cities, total number of restaurants, and also provide a specific score. So the default is all score based on its K. We will find top K population cities in specific partitions. Then we traverse restaurant partition and filter the restaurant with the city name as specific city. And we add the length of the total array to get our MapReduce result. That's how we doing MapReduce in SQL. That's our logic so far. And thanks for listening.
Now let me introduce our web app. So our web app includes 3 different tabs. The first one is for the SQL implementation of the file system, and the second one is for the Firebase implementation of the system. And the third one is called Organization. It is supported by different MapReduce functions that we created. For the emulated file system, SQL and Firebase got the same kind of UI interface. However, they are supported by different platforms. For the SQL, I will introduce first. You see on this part, this is the system emulation of files. And if you click into it, you will get the subdirectory. And if you click into it, you will get all the files included in this folder. So this is the LS functionality that we realized, the API. Second, the make-dir. If you want to make a new folder under this directory, like you want to call this folder, SAMP, and it's not a file, right? So you unclick this file, and it will only have this option showing up. When you submit, you got the SAMP folder on this directory. For the remove, you can simply delete, and it will removed. You can also delete Amy, and you can delete user.csv. So when you refresh this page, these folders are gone permanently because it is connected to our API and is connected to the database. I will also give a little bit demo on Postman to show how our backends works. Like get all paths. If you click send, it will show all the paths that is currently under this directory. It has user, join, test, user, city, CSV. And if you go back and you type a new directory called Picasso maybe, and it's a directory, and you submit, and you go to see this Postman and send again, it will have this new Picasso directory showing up. So it is all connected. Also, for the for the information of the files, we have get partition of files and read partition functionalities. And if you open this file, it will show the location of the file as well as the content. Okay, that's the introduction of SQL part. For the Firebase, it is basically the same thing. And it is connected to the real-time database, this one. And I will give a demo of how this real-time database works. So if you want to enter a directory called maybe Amy under this folder, it has a new Amy folder showing up. And if you log into this Firebase real-time database, you will find that Amy is here. So there's a D in front of Amy introducing, we introduce this D to represent that it is a directory. And if it's a F, it's a file. It's also showing up differently on this UI. And if you delete the rest, rate 1 or rate 2, and you go to the Firebase again, these two are disappeared. So it's all connected to our database. And if you go into under the user directory, you go to the next one, is ls. And you have restaurant, you have rate 1, rate 2. And if you want to put a new file called rate inside this directory, and you got 3 partitions, you want even partition, and you submit, you got all those 3 different rates files that are partitioned. So if you click onto it, it has the location of this file as well as the information of this file that is fetching just now. So they all have the location and the content. Okay, and then I will introduce how the analyzation part works. These analyzation parts are all connected to the MapReduce function that we have. And for the first one, the top restaurant in our city, you can simply enter a city name and you select the 5 rating range restaurant. You got all the ratings that are 5. So if you change this to maybe 2 and submit, we got also the changing list. In this MapReduce function, we can simply select the number of restaurants that are top, that have top review count. So if you want to just see the top 1, you got 1 restaurant, and you want to say top 10, you got 10 restaurants. It's all showing up directly. And for the population and restaurant, we can select the minimum rank and the maximum rank of a city, and this method will display all the restaurants in this city and showing up the relevant values. For example, if you want the minimum to be 5 and the maximum to be 10, then you will got all the ranges that are between 5 and 10, and you will have the population, the number of restaurants, so on. Okay, that's basic part of our web app. Yes, and I want to also introduce a little bit about the code that we use. We basically have backends and frontends. Frontends is using React framework, and backends is using all the is to implement all the APIs. It's based on Django framework. And for the Firebase API, since it's really straightforward, it is implemented inside the React framework. Inside this home.firebase.js file, it includes all the information of the page that's supported by Firebase. So several functions were made, like write data, delete data, read data. There are means different APIs. This means make dir, put, this means remove, and this means ls. Also, we have cat that reads the content of the file. Yes, and that's the way that we implement the Firebase API. Thank you. That's all for me.